What is kinematics? You guys will tell me.
Study of motion of objects.
Okay. What comes under the umbrella of kinematics? Well, like what comes under the umbrella of kinematics? All of you have read the chapter of NCERT or HC Verma or something of kinematics?
Displacement, velocity.
Okay, displacement, velocity, acceleration. These things come in kinematics. Force comes into kinematics or not?
No, sir, because force deals with uh, uh, the reason for the motion of objects.
Yes.
While in
So here,
kinematics, we just study the motion of object and we don't interfere with how the object
moves.
undergoes, how the object moves.
Okay. So study of motion of the objects without worrying about the reasons. This should be the actual definition. Study of motion of objects is correct, but we don't worry about why the subject is moving or why that object is moving. Okay, we just worry about it is moving. That's all. So we worry about displacement, we worry about velocity, we worry about acceleration. We don't worry about force in kinematics. So Newton's laws of motion are not part of kinematics. They are part of something called dynamics, where we actually worry about the reasons why actually the thing moves. Okay, so we worry about force, there we worry about energy, there we worry about everything, torque and everything. But in kinematics, we just worry about motion, nothing else. Why it started moving, we don't know. We don't want to talk about that anyways. So that's the reason. Yes, moving on. Why do you want to study kinematics? Your ideas? Why I'm starting the syllabus of classical mechanics with kinematics? Why not directly with Newton's laws of motion? Why? Or why in every textbook they start with kinematics, not the Newton's laws of motion?
Because there are some things which we have to know before the studying the actual reason for the motion.
Okay, okay. Sorry, पूरा last का ही सुनाई दिया. So the full answer.
Because
Can you repeat?
there are some physical quantities we have to study before the studying the why the motion arises. So that's why we study the kinematics.
Yes. So when things are moving, we need to describe its motion. And if things are moving, there are always some reasons associated with why it is moving. It is not moving without a reason. So kinematics is just a textbook thing. There is nothing which is moving without a reason. But we just don't worry about those reasons in kinematics. But in real life, what we apply, we always apply dynamics. But why then? Why do we study kinematics? The reason is, as Mustafa said wonderfully, we want to get ourselves equipped with all the tools required to study dynamics. So there is an old saying that tells you that if you want to cut the tree for 5 hours, spend your time sharpening your axe for 4.5 hours and just cut the tree in half an hour. So this is sharpening your axe. You just want to sharpen your axe so that you can cut the tree for a very good amount of time. So if you want to, there is a saying, if you guys know this or not, If you really want to cut a tree for 5 hours, sharpen your X for 4.5 hours. Don't just go and just cut the tree. For first day, you will cut the tree nicely, but you won't be able to cut it with the same speed on the next day because your X is now not sharpened. So do sharpen your X every day. And this is sharpening your X. So that's why we study kinematics. We want to understand what is displacement. We want to understand what is velocity. We want to understand what is acceleration. And after that, we can understand what is force and what force does. Okay, so we want to understand these terms before going to kinematics. Yes, moving on. Something called reference frame in kinematics. So whenever we study kinematics, there is something called reference frame. In all the classical mechanics, there is something called reference frame. What are your ideas about reference frame, Swati?
Sir, I think it's our point of our point of view of the object, like or the there are different kind of a reference frame. One is observers and the objects. So the point we view from is, I think, is the
So our
reference
point
frame.
of view of, okay, we want to view something. So it is our point of view, right? Reference frame.
Oh,
Okay.
yes, sir.
Our point of view of studying the object
Right.
is our point of view of studying the object of studying the motion. Anybody with some better set of words? These words are exactly accurate, but they will not give the same level of understanding to everybody. So some better set of words. Somebody want to try? Okay, here I am assuming that you have studied the book by H.C. Verma. You have studied at least the theory by H.C. Verma of the chapter kinematics. If not H.C. Verma, your NCRT, or if not NCRT, Resnick and Halliday, something you have studied for kinematics.
Sir, it
Yes.
is our frame, our referenced frame, which we decide to study the motion of that object or that
So
about.
reference frame is our reference frame. Do you think this definition is consistent? Reference frame means our reference frame is okay. Think about something else.
The frame which we took for our convenience, from which we calculate the motion with respect to that frame.
The place from which we see the universe is our reference frame. Okay, the universe or the motion or whatever you want to see, the place from which we see that is our reference frame. This is a very vague definition. Very vague. This is also very vague definition. But these just tells us that yes, we know what it means. So suppose this is a wonderful example. Whenever you are sitting in the train and going from suppose Karnataka to Rajasthan. Okay, so what you say, you don't say I am going. Okay, whenever you are inside the train, the stations come. You don't say I am going to that station, right? This is our usual set of words. If you will observe carefully, what we say is next station, next I think what will come? Chhattisgarh. Sorry, next Nagpur will come. Okay, so we'll use these terms. Nagpur will come. Actually, Nagpur is coming, or we are going to Nagpur. These are our set of words because we are sitting in one reference frame from which the stations are coming. We are not going anywhere. But if we are standing on the platform, we'll say the train will come. So this is the difference between the reference frames. In one reference frame, you will say Nagpur will come, and in the other reference frame, you will say train will come to Nagpur station. So if you are standing on the Nagpur station, you will say train will come to the station. If you're sitting in the train, you will say next station is Nagpur, so next Nagpur will come. How many of you use these kind of words in your real life? Yes. So you guys know that I'm not talking about something out of the world. We use these terminologies because of our reference frame. Okay. So in general basic definition of reference frame is the place from which we see the universe, but it just does not make a complete definition, because there can be 1,000 places from which we see the universe. Yes, those 1,000 places are all the reference frames, but we want to measure the motion of the particle from that reference frame. So what do? We always attach a set of axes, a coordinate axes, either they are Cartesian or they are spherical or they are cylindrical or whatever. We attach the set of axes with each and every reference frame. So if we are sitting inside a train, there is a reference frame called train, and we attach a set of axes to that person in the train. So that person in the train sits at the origin. And now if the Nagpur is here, and the Nagpur, okay, so there is a house in Nagpur which is here. And then after some time that house in Nagpur appears here. So you say that, yes, Nagpur has came. Actually, Nagpur or this house has not came, but if you feel that this house is moving from this direction to this direction, if you are sitting in train, okay, so you always attach a set of axes to each and every reference frame, just because you want to measure the distances, the velocities, and all those things. So you measured this distance t1, you measured this distance t2, and then you concluded, yes, this house moved. This house moved, and that means that house came to you. You didn't went to that house. Okay, there can be another reference frame of platform. This is platform, and where you are always on the origin. So you attach origin with yourself. You consider yourself as a point particle. Then you attach origin with yourself, and now from your reference frame, this reference frame is moving. This reference frame, the complete reference frame, is moving in positive x direction. Suppose this is x, this is y, and this is z. And this is for another reference frame. Let's name these set of coordinates x prime, y prime, z prime. So these set of coordinates are actually moving towards you in positive x direction. So this reference frame is moving to you in x direction. This is what you get together if you are in the reference frame of platform, because this reference frame was here at time t equal to t naught. After some time, it will be here. So we always attach a set of axes to the reference frames. Without set of axes, reference frames are meaningless. Okay, because we want to anyway study the motion from reference frame. So if we can't study the motion, there is no point. And how can we study the motion? We need to study the distances, the displacements. And from distances and displacements, we study from some reference points. Those reference points are given by these origins or these set of coordinate axes. Okay, so we always attach a set of axes to the reference frame. So this is the complete our idea of reference frame. Okay, whenever now I'll talk about reference frame, you will talk about reference frame, we'll assume that there is some set of axes. If not given properly, we'll assume that there are some set of axes. We'll find out those set of axes. If they are given, then it is one. Yes, moving on.